This next example is a little difficult, and some of you may want to come visit me to discuss it a little bit further during office hours or during our next live class. So right now we're asked to find theta, all theta in radians, and it's giving us the secant of theta is equal to 0. So first thing we have to remember is secant and cosine are reciprocal functions. Cosine, cosine is defined as adjacent over hypotenuse, and if we're working on a circle here, it's the x coordinate divided by the radius of the circle, which means secant is a reciprocal of that, which is the radius value divided by the x coordinate there. Okay, so considering that, if the secant of theta here is equal to 0, right? For any ratio to produce 0, that means that the numerator has to equal 0. So kind of translating that to this would basically say that the radius length of the hypotenuse, however you're viewing it right now, would be equal to 0, which means you don't really have a circle to work with. Okay, so that would be the first red flag that pops up. In that situation, our answer to the question would be no solution. Right. Another way to look at this is because the secant function and the cosine function are reciprocals, if you attempted to take the reciprocal here of 0, it doesn't exist. You can't take the reciprocal of 0. You could, one way to help you make sense of it, this isn't really the best way to do it, but it might help you make sense. If 0 is expressed as 0 over 1 as a ratio there, then the reciprocal of that would produce 1 over 0, and you cannot divide by 0. This ratio right here is an undefined value, so it doesn't exist. That's also another way to kind of help us make sense of this here, right here. So since cosine of any angle as we rotate around the circle is defined, which means you get a value in return for any angle, positive or negative, around the unit circle. There's no possible way that we could take the cosine of an angle and get an undefined value. It's just not possible. It's not the same as, but similar to when you had that review question where sine theta is equal to 2. That's not possible because the sine function is defined between for all values around the circle between the values of negative 1 here and positive 1 here. And since this is saying sine theta equals 2, there's no way you would get a y coordinate value for any angle that's larger than 1 or smaller than negative 1 there. So again, this piece about sine, it's not the same thing, but it's just trying to help you make the connection between when you have an undefined value or not. If you get stuck on that, come by and visit and we'll talk about it. I'll try to give you another visual to make sense of it. Next example, I think it's equally as complicated as the previous one. Cosecant theta is equal to an undefined value. With ratios, we get undefined values when we 0 in the denominator there, right? So that's the first thing we kind of need to keep in mind. Whoops. So this is basically telling us that our cosecant of the angle should have some kind of 0 down there in the denominator, regardless of whatever the numerator is. So in this case, this we can kind of work with a little bit. So if we think about secant and sine being reciprocals here, we're just taking the reciprocal of the ratio right there, r over y, y over r. So for cosecant to be undefined, that means we would have a 0 down there in the denominator. So then what I can kind of think about is that, well, then that means, that my y coordinate is probably 0 at this point, or has to be 0. And I'm not really sure what the r is at the moment, but it doesn't matter. So kind of using this concept and then kind of translating it to the sine function to help us make sense of it, then that would mean sine of theta is equal to 0 over the r value at this point, which is saying that the y coordinate here has to be 0. So I'm going to translate this concept over to the unit circle and look at, so where are my y coordinates? What angle measures are my y coordinates 0? So right here I have the point 1, 0, y coordinate is 0 right there. And then over here, I have the point -1, 0. So my y-coordinate is 0 right here. So I have two angles. I have this first angle right here, and then I have another angle all the way over here. Both of those angles are a total of pi radians away from each other. So at this point, I can start listing my angles. I can say my first angle is 0 radians, right? And then I have another angle over at pi radians right there. And again, if you continue to think about, since we're finding it for all values of theta, right? Every half a rotation around the circle, I'm back at one of those coterminal angles that satisfies this, right? So you go 0, pi, 2 pi, 3 pi, and so on. And this is a case where we would turn around and say, well, beta is equal to 0 plus pi n radians, or we can kind of condense this even further and just say it's pi n radians. So all pi n radians will satisfy this scenario. Next example we have here is cotangent theta equals -1. Right? So a couple of things. We're going to kind of approach it in a similar way we already have, where I'm looking at the cotangent of theta right here is equal to the x-coordinate over the y-coordinate. Cotangent is reciprocal of the tangent function. Tangent is y over x. Then I'm going to focus specifically on the positive negative sign here. We couldn't really do that here with undefined, and we really couldn't do it here with 0. But in this case, it's saying that the cotangent is negative. So now I'm going to relate that to the quadrants in which our trig functions are positive. So they're all positive in the first, sine's positive in the second, tangent's positive down there in the third, and then cosine's positive in the fourth quadrant there. So since cotangent is negative, cotangent and tangent share the same positive and negative signs where those angles terminate in this respective quadrants. That means that we cannot be in quadrant. We cannot be in quadrant 1, right? So that's out of the way. Sine is the only positive. Sine and cosecant are the only positive in the second quadrant. So that means that we could have an angle there in the second quadrant. Tangent and cotangent are positive in the third, so the third quadrant's out. And then cosine is positive in the fourth, along with secant, which means that cotangent and tangent are negative. So we have two quadrants where our angles could be located. So let's look at that. So that means that I can have an angle somewhere in the second quadrant. We'll focus on that first. The other thing we want to look at is this value of 1. When you take a ratio, right, it's a division problem, and divide one value by the other, the only way to produce 1 or -1 in that case is where, the number in the numerator and denominator aren't the same, but they're opposite values. So for example, 2 and -2, or -3 and 3, that they all simplify to a -1. So the x and y coordinates have to be opposite signs in this case, right? So basically, you're going around the circle and you're looking for, where on my circle do I have points that are opposite values, right? So all the points in the first quadrant here are positive, so that's why we ruled out the first quadrant. But over here, I do have, I have a negative x coordinate and a positive y, and there is a coordinate point right here at √2/2, or -2/2, comma positive √2/2. Right? That coordinate point, those are opposite signs, and if I were to take the ratio y over x for the tangent, or x over y for the cotangent, they both, that ratio will simplify to a -1 there. √2/2 side lengths for triangles produce 45-degree angles, or pi/4 radians. So basically, this is a 45-degree angle, or a pi/4 reference angle that I'm looking at right now, which would essentially make the big angle right here, in terms of radians, 3 pi/4 radians right now, assuming that this is a pi/4 radian. That would also put us at 135 degrees if we were working in degrees there. Now, so that's one angle. And then let's focus on the other potential angle, right? So down here in the fourth quadrant, same thing. the signs in the fourth quadrant, positive, negative signs. We have a positive x and a negative y, and then there's this other point right here, you know, for an angle with the reference angle right there, where I have the point positive root 2 over 2, comma negative root 2 over 2, right? So it's not the same point as this point, but it's their opposite coordinates there. Again, if I took the y, coordinate divided by the x coordinate, for the cotangent relationship, I simplified to a -1. Excuse me, for the tangent relationship. And if I were to work with the cotangent relationship, I would take the, the x coordinate divided by the y coordinate. And in both cases, I still get a -1 there. Again, this angle right here is a 45-degree reference angle, or pi over 4 radian measurement. So then if I were to try to calculate this whole angle here in radians, that's going to be 7 pi over 4 radians right now. That's that big angle, 7 pi over 4. Other things we have to kind of keep in mind with this is we're looking for all values right now. So we have to go back, just focusing on the angle in the second quadrant there. Every full rotation from this blue angle, all the way around back to itself again, is another coterminal angle that has the same set of coordinates, which is going to produce the same cotangent value. So you could turn around and say, well, it's 3 pi over 4 plus 2 pi n, and then move on to the green angle down here in the fourth quadrant. It's the same concept. Every full rotation from this angle right here, right, all the way around again. So that would be 7 pi over 4 plus 2 pi n radians. It gives you another set of coterminal angles for the fourth quadrant angles down there. Right? But we can generalize this and simplify and make it a little easier, because if you kind of pay attention to what's happening here, every half a rotation from that first initial angle there, blue, right? That's a half rotation. I'm at another solution. I go another half rotation. I'm back at another coterminal angle that gives me the same solution. So we can generalize this and just say 3 pi over 4 radians plus pi n radians. Every half a rotation around the circle, it's us back. So you can say theta is all 3 pi over 4 plus pi n radian angle measures.